we're going to have a look now at ordering fractions. Now, if you haven't already watched our video on equivalent fractions, I would really recommend that you watch that first, because that's going to be the number one skill that we use here. Okay, so we're going to put these fractions in order from biggest to smallest. And I've got 3/4 and 4/5. Now, I've got kind of a picture in my head of what these should look like. So 3/4 looks a bit like 1, 2, 3 bits out of 4. And 4/5, it's like I'm splitting this into 5 pieces, and I'm taking 4 of them. Now, you can kind of see from this that 4/5 is a bigger number. It's shading more of a whole unit than 3/4, okay? But that is not what I would call a rigorous mathematical proof, especially because these two pictures are both pretty scribbly. Do you know what I mean? And if I had more difficult fractions like 45/76 and 37 out of 53, you wouldn't be able to draw them accurately, okay? So we need to have a proper mathematical method to do it as well, okay? So what I'm going to do is use equivalent fractions, okay? Now, I can't compare these two directly because this one's split into 4 bits, this one's split into 5. But what if I split each of these 4 slices into 5? Okay? Maybe not going to do it for all of them, but imagine each of them getting split into 5. So each of those 4 pieces split into 5, so I'm going to have 20 pieces. Okay? And now over here, I'm going to split each of these 5 pieces into 4. Okay? And then I'm going to have, I started with 5 slices, but it's like I'm multiplying it by 4. Each one's getting 4 times more slices in it. So if I carried that on for the whole shape, I would have them both out of 20. Okay? And my numerators, okay, are going to be, well, here I had 3 times 5, it's 15. Now 15 out of 20. Here I had 4 slices, each split into 4, that would be 16 out of 20. Okay, and now we can compare them very easily. Okay, all I've done is times 3 times 5 and 4 times 5. Remember, to get an equivalent fraction, the same fraction, I need to multiply top and bottom by the same thing. And here I've multiplied by 4, top and bottom. So my new denominator, I've got 4 times 5 and 5 times 4. They're obviously both the same thing. And now I can compare them very easily. Look, 15 is smaller than 16. So if I'm putting them in order from biggest to smallest, I can write 4/5 is bigger than 3/4. Put them in order. And I always like to give a reason, okay? 16/20 is bigger than 15/20. Here I've got 16 of them, and here there's only 15, okay? So it's bigger, okay? For the next one, there's 3 numbers though, okay? So I need to think of a number that's in the 5 times table, it's in the 2 times table, and it's in the 3 times table. And the easiest way to do this, see here how I multiplied the 4 by the 5 and the 5 by the 4, is if I multiply this by the 2 other numbers, 5 times 2 times 3, okay? Now, to get an equivalent fraction, if I'm multiplying the bottom by 2 and 3, I also need to multiply the top, the numerator, by 2 and 3, okay? Here I've already got the 2, so I need to multiply by the other 2 numbers, the 5 and the 3. And if I'm multiplying the denominator by 5 and 3, I've surely got to multiply the top by 5 and 3. Here I've already got the 3, so I'm going to multiply by 2 and 5. And then I've got to multiply the top by 2 and 5. Okay? So now I've just got a load of times tables to do. I'm going to say now, see, for fractions, the number one skill that it would help if you had it is if you knew your tables. Okay, so if you don't know your tables and you've just started doing fractions at school, really, please, 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 try and learn those tables. Try and get as much times table practice as you can, because it will make your life so much easier if you just know all your times tables instantly off the top of your head. Okay, so I know it's very, very difficult for some people, but really, please try your best and keep practicing. And don't lose heart if you find your tables a struggle, okay? Just keep battling through and you'll get better at them, okay? So let's do the top one. 3 times 2, that's 6. Times it by 3, we've got 18. And on the denominator, 5 times 2 is 10. 10 times 3 is 30. Okay? Now I already know that these ones are going to be out to 30 as well, because that was the whole point. Okay? So I've got 2, 5 and 3 multiplied. It doesn't matter what order I'm multiplying them in. Okay? On my numerator here, I've got 1 times 5 is 5. Times it by 3, that's 15. Okay? Here on the numerator, I've got 2 times 2, that's 4. Times it by 5, that's 20. Okay? And now I can put them in order. Okay? So I've got 18, 15 and 20 as my numerator. So 20 is the biggest. So 2/3 is the biggest. That's bigger than 18 is the next. That's 3/5. Okay? And that's bigger than 15/30. That's a half. Okay, and let's just write in my reasoning, since 20/30 is bigger than 18/30, and that's bigger than 15/30. Okay? So here it's hard to see which one's the biggest, and when I put them all with a common denominator, it's very, very easy to be able to say that 20 is bigger than 18 is bigger than 15. Okay? Last one, I've just done one more with kind of trickier numbers, okay, just so we can practice our times tables a little bit. Okay, so I'm going to do 3 times 7 times 8. So I've got all my denominators multiplied together. So here I would need to multiply by 3 and 8. Here I'd need to multiply by 3 and 7. So I've got a 3, an 8 and a 7 in each denominator. I'm going to have the same denominator. And then I just need to multiply all my numerators by the same thing. Whatever I've multiplied by on the denominator, I need to multiply by on the numerator. Okay, and let's get a bit more space because I'm going to need to set out some working here. Okay, now 2 times 7, in fact, let's do 7 times 8 first. 7 times 8 is 56, and then if we do 56 times 2, you can maybe do that in your head. 6 times 2 is 12, 5 times 2 is 10, add on the 1, 11 for 112. So I'm going to have 112 on that first numerator. And I've got 3 times 7 times 8. Well, I've already done 7 times 8, so let's use that again. But I'm timesing it by 3 this time. 6 times 3, that's 18. 5 times 3 is 15. Add on the 1, 16. I should be putting all my working in the boxes really nice and neatly. But here we are. Okay, so now all of them are going to be out of 168. And now, if you think back to how we drew the first one, and that kind of made sense because I had it split into 3s and 4s, you can see how it would be very, very difficult to draw an accurate drawing, even with like 4/7 and 5/8 to compare that, let alone drawing 112 out of 168 really accurately. So the mathematical way is better. Okay, so now I've got 4 times 3 times 8. 4 times 3 is 12. I'm going to times it by 8. Maybe you know your 12 times table, in which case you're laughing. 2 times 8, that's 16. 1 times 8 is 8. Add on 1, 96. And then 5 times 3 is 15. I'm going to multiply that by 7 for my last numerator. 5 times 7 is 35. 1 times 7 is 7. Add on the 3 is 10 for 105. Okay. And now I've got my 3 numerators, 112, 96, 105. I can see that first one's the biggest. So 2/3 is the biggest. Okay, 5/8, that's in the middle. And that's bigger than, 105 is bigger than 96, so that's bigger than 4/7. Okay, and this is because 112 out of 168 is bigger than 105 out of 168. And that's bigger than 96 out of 168. See, in an exam or something, make sure you've got this working as well, okay? This is a very nice sentence, but kind of this is the powerhouse, all these sums. Okay, so make sure you include your working. Good stuff.